Yeah,
So-
it's on the bottom.
So the top is 31.4. The
Divided
bottom is
by 3 times 9.8.
3 times 9.8, 29.4.
Why is it?
So 3.14 divided by
Arc
29.8 is equal to, then you do.
Why is it the arc sine?
Yeah.
We're trying to find the angle. If I have sine of theta 3 is equal to this.
Right.
If I need to get the angle, I need to get rid of the sine, and you get rid of the sine by doing the arc sine. So you would take the arc sine or inverse sine of both sides, arc sine of both sides. Those would cancel each other out, so I'm left with theta 3, and then I'm left with the arc sine of this.
Okay.
All right,
Yeah, I'm still getting.
Okay, wait, I think I can do it.
So 29.
So are you getting like a number that's like 1.06 whatever before you take the arc sine of it?
Let me try.
I tried to separate it.
Wait, I
out.
still got error. I really thought I had it.
Yeah, because it's 31.4.
Wait, where did you get
it? 3 times 9.8 is 1.068. And then my arc
It's
sine
still
of that
there.
is gonna be fine.
Well, it has to exist, right?
29.4 is 1.068, and then arc sine of that is error. What do we do?
Can you tell me that we're just typing in numbers right now?
what does this mean?
That it's
So it's y divided by.
this used to happen in one of the classes I was in for math, but I don't remember what we did about it. No.
It's like getting a negative under the radical. There's two possible interpretations.
Then,
Or
There's two.
I missed the last one.
it is there.
Yeah, it's one of those two. Now, considering several of you have come up with an error,
I got an error too.
Yeah. What's the largest sine can be?
One.
1.
That's
Oh,
why.
yeah.
So when we, okay,
Oh, I keep forgetting.
so this is where my brain went with this. Thinking about the error, it was like if one is the largest sign could be, I was thinking about the different quadrants that we used to do and how we have to subtract like pi from whatever to get it correct. Is this similar to that? Like we're just in the wrong, like it's going.
It's not the
around,
wrong quadrant.
starting from-
It's the fact that the largest that theta 3 can be is 90 degrees.
Okay.
And at 90 degrees, it can't be in equilibrium. That the force of gravity acting down on 3, in that situation, the force of acting down on 3 in that situation is that much, and that's not enough to overcome the other one. So I have done things like this on a quiz,
Oh.
and after half of them were handed in and people left, because they did the quiz at the end of class, somebody said, "Is this problem possible?" To which I responded, "Oh yeah, oh, wait, just a second, oops." So we redid the quiz, and I made the same mistake again. The third time I got it right. So, but this is a situation here where it's not possible.
So the angle, so there's no angle at all.
So the answer is just,
It can't be done.
okay.
Oh my. Are you serious?
That was not my intent when I wrote it up, but this is what happened.
Oh,
So what would we write? N-A.
Yeah.
Are you serious?
really?
No problem.
And then, show why you're saying that, because I'd hate for it to be, you'd write NA because you got an impossible answer, and then it turned out that you just made a careless error.
So you made this question and made it to an error by pure accident?
Yeah, this was a mistake, so I'm gonna change something
I
here.
was kind of impressed that you wrote it and then it came out as an error. Like, oh wait, how did you figure it out in like 2 seconds?
All right, so I'm gonna change this to 4. I'm gonna keep the subscript 3 just for historical reasons, but the only thing that's changing is this M3 is now a 4. I was about to erase. There we go. So 4 times 9.8
0.2.
Oh, okay.
Now you should be getting a real, a legitimate answer.
So arc sine of 0.801.
Arc sine of 0.801,
The mass. It was 30.
And
and
then
what do we get for that angle?
53.23 degrees.
53 point,
23 degrees.
all right.
Yeah, it looks like,
So the original problem, for those who
so you changed that.
missed it, that's the original problem, that it's frictionless, and I said it was in equilibrium. What is this angle right here? So obviously, we do need to change this so that it matches our new reality here, so that's a 4, and I'll just keep that as theta 3.
But it's supposed to be 30 though, so it would equal 180. If that was a right triangle.
Oh, it's not a right triangle, but if it were a right, well, if it's a triangle, it should add up to 180. So we could actually find this angle now, because that was 53.23.
Mm-hmm.
So what is that angle?
86.77 degrees.
Almost a right triangle.
Just a little bit up.
That was just for fun, that we're not doing anything with that angle. Other than emphasize the fact that if I draw it and it looks like it looks like a 90-degree angle, do not assume it's supposed to be. Level, yes, it looks like I was meant to draw level, fine, but angles, no.
May you please, go back to where you had all the equations?
What are the next one?
No, one more, please. Yeah.
No, okay. Ah,
Just gotta, read it again.
I'm about to change the question.
Wait, I'll just take a picture. Thank you. I didn't have you in it originally, like I zoomed in enough, but then I saw your hands and I was like, I'll throw them in there.
You know, I have to show off that I learned something from The Price is Right.
More like Wheel of Fortune,
Was that
the lady.
Anna White?
Yeah.
Or
I
her
knew.
predecessor, Susan Stafford.
Which do you prefer?
She was the first.
Okay.
Yes, I am so old,
I don't
I watched
know
it back
Anna
when Susan
White.
Stafford was the letter turner.
I don't know the other. Maybe if I see a picture of her, I'll.
I doubt it. She wasn't around very long.
Why'd she quit?
I have no
That's a
idea.
great job.
Okay, next. We're now going to change theta 3 into half of what it was.
So just half the angle.
Half of what we just got.
So
So now the problem is, I've got my 40-degree angle here. I got my 5 kilogram mass there. I have my 4 kilogram mass here, and this angle is now
26.15.
26.17,
15.
15.
Wait, did you get the same? Oh, hold on.
Wait, this is completely new.
26.
All I did is, we took the answer they got for the first part, and I said, we're cutting that angle in half.
I'm sorry, it's 26.615. I'm reading this like a crazy person right now. Thank you.
Now the question is, what's the acceleration?
No.
It was in equilibrium before, so that was just delicately balanced, so if I change either angle, it's not gonna be in equilibrium anymore. All right, so at this point, we've done the force diagram, so that's not changing. We might want to look at changing our coordinate system. Which way will it go now? If I made the angle on the right side half of what it was.
It'll go this way.
Yeah, this way.
Okay. Now, it's without friction. If friction were involved, it does matter. It matters a great deal about which way it's going to go, because friction, that's going to determine which way friction would act on it. Without friction, let's just, for the sake of this, stick with our same coordinate system. I agree, it's gonna go that way, it'd be really nice if our coordinate system were flipped, but I just wanna show what happens if we guessed wrong. So our equations of motion are still gonna be the same as we had before, except not equal to 0. Well, at least two of them. So we'd have Ft minus W5 sine theta 5 is equal to mass 5 times A. We have W5 minus W5 cosine theta 5 is equal to, that's still equal to 0. Because it's perpendicular to the acceleration. We have W3 sine theta 3 minus Ft is equal to mass 3, which is actually a 4 kilogram mass, times A. And then Y3 minus W3 cosine theta 3 is equal to 0. All right. The only difference between this and what we did before is acceleration is not 0 for the equations parallel to the ramp. I'm going to flash back quickly just so that you can compare it to what we had before. That's what we had before, where they're all equal to 0, but that's changed and that has changed. Now that it is not in equilibrium anymore. And it's now yellow. Substitution is still the next step. What are we substituting?
Weight is equal, yeah.
So I have Ft minus M5G sine theta 5 is equal to M5A, excuse me. And then M3G minus, sine theta 3 minus Ft is equal to M3A, excuse me. And now
Can we set-
solve. We know everything except for we don't know tension, we don't know acceleration. I did, yes, there's a substitution that would happen here and here, but without friction, those two equations really aren't gonna matter in this problem.
Is it
I
still
should
nine?
reword that differently, because there's no friction and no acceleration in those directions. They're irrelevant to the problem. Robin?
Is it still 9.8?
Yeah, we're still on Earth.
Okay.
So if I just add them together, if I add the left sides, I have tension and negative tension, they'll cancel out, that is convenient. So I'm left with M3G sine theta 3 minus M5G sine theta 5 is equal to M5A plus M3A. Let's factor out acceleration. So I have M5 plus M3A. And so now divide by the total mass, and we have our acceleration. So our formula for acceleration is M3G sine theta 3 minus M5G sine theta 5 divided by M5 plus M3. And the answer is
I got to 2.29 meters per second squared.
I'm not buying that.
Okay.
Did you forget to say something? Did you leave something off?
That's the one I got on my calculator. Let me look at it.
I definitely would expect the answer to be negative.
Negative? Oh, I flipped it.
What do you got?
Negative 1.55. Oh, you want me to do 54836 meters per second?
Squared.
Yeah, that's the part I was scared after about. All right. So what does the negative acceleration tell us here?
It's going the opposite direction than the indicated acceleration that we said earlier.
Yeah. So, as was said earlier, we're expecting it to be going this way, but if we chose a coordinate system so that's the positive direction, negative acceleration means it's the other way. It's not like the situation of a box on a ramp where suddenly we plug in our maximum static and it ends up with a negative acceleration, making it seem like it's suddenly going to be going up the ramp. That's a different physical situation. Here it could go either way. So in the test problem, what I had done is I did set up the first one where it actually was a real answer. Then I either doubled an angle or I cut one in half, asked what the acceleration was, and then I added friction into it and asked what the acceleration was then. That was the full test problem. I am going to stop it there. I mean, the rest are just variations on the theme. So we'll say Monday the 23rd, master set 4-5 application.
Wait, Monday the 23rd, master sets did.
The master set chapters 4-5 application. There's concept and application. The application one,
Is concept due before that?
the concept is bound for the 18th.
Oh, yeah. Okay,
When?
so concept, the 18th. Application.
I'm guessing our test is on the 25th.
And test is on Monday.
No, like for test 1B.
Oh, 1B, that,
I feel
we're
like.
gonna do chapter 6 first, and
Oh,
then we'll assign that.
also we're doing 4, 5, 6.
Okay. 6 has a twist of things traveling in an arc at constant speed.
So we have to do 2 tests in a matter of almost 1 week.
Yeah.
Sign 26.
All right. Yes, Lauren.
This is, but can you explain, I think I'm getting this wrong because I'm looking at the diagram. When you guys were plugging in the numbers that was, whether it was sine theta 4 or sine theta 5, I think I'm plugging them in backwards, but in my brain it makes sense because I'm looking at it on this train that we have for the ramp. So like, I'm not getting the negative number, and I put theta 4 here.
The 5 kilogram mass is what with the 4-degree angle. So your angle.
Okay, thank you.
Yep. All right, so what we're doing next is lab. It is a friction lab. And I need to go grab them and figure out what we're missing. Oh, I know one thing we're missing. I'll grab it on the way back. And for those who